The next low-tech video you're getting today, ladies and gentlemen, is your heating curve. So this is a heating curve, the basic shape. Really, this line should be longer, but I was in a hurry and my battery is dying on my phone, so just gonna have to play along with me here. Remember that right here, if this was for water, we all know that water freezes at 0 degrees and it boils at 100 degrees. What students forget is that it freezes or melts at 0 degrees and it boils or condenses at 100 degrees. It depends on whether it's really a heating curve or you look at it backwards as a cooling curve. So remember, the biggest question on the test, it is 5 steps, or quiz, don't freak out, quiz is 5 steps, but I don't have time for that. My lovely children, it's 5:07 and I need to get home to them because they're hungry, I'm sure. They're gonna be whining like nonstop. Okay, so let's go from, let's go from 50 because that's a nice round number. Oh, I have no calculator ready for this. We may do it without calculators. And let's go to 110. Okay, so it might say, how much energy does it take to heat up liquid water, 75 grams of liquid water, from 50 degrees Celsius to 110 degrees Celsius. So this is where at each time the line changes directions, you have to do a separate step. So this would be step 1, step 2, step 3. Anytime there is a temperature change, you can use Q equals MC delta T, because that temperature change means that you can actually use that equation. So here and here, we can use this equation. But right here, there's not. So that's where we can use Q equals our mass times our heat of vaporization. So be very careful that you're using heat of vaporization right there. Let me get my cheat sheet of values here. Okay, so, you'll be given your values. You won't have to have them memorized, but if you were given water, the C of liquid is 4.184 joules per grams degree Celsius. Feel free to fast forward as I'm writing all this because it's going to take forever because it wasn't prepared. By the way, y'all can thank one of your classmates for these lovely videos, because I was like, I don't have a YouTube video. And she was like, you should. So here you go. Isn't that nice? Oh man, this is in kilojoules per mole. I don't want to do that. Oh well. I bet your quiz is like that. So that's okay. We shall do it. Now, these are all the values that you might be given. Your answer needs to be in joules, so you got some work to do. Now, because I'm doing these 3 sections, I'm doing liquid, vaporization, and gas, which means I do not need my solid one, and I do not need my fusion one, so we can completely ignore those. Now, I'm going to start with step 1, and I'm kind of writing while holding my phone, because this is low tech, that this is going to be a little difficult, but that's okay, bear with me. I get to use this equation. Your Q is what you're looking for. Your mass is 75. Your C is for the liquid, so make sure you're picking the liquid one, 4.184, times your change in temperature just for this segment. So that's 100, because that's the 100 point right there, minus 50, so that's going to be 50. All right. See, I'm still here, just for you guys. I'm grabbing a calculator. All right. Let's go. 75 times, it's not even on. Really? There we go. 75 times 4.184 times 50 gives me a Q of 15,690 joules. All right, step 2 is mass times heat of vaporization. That's wrong, because these units are moles, so actually this is going to be moles, which means I have to do a conversion. I've got to take my 75 grams of H2O and I've got to convert 18 grams of H2O in 1 mole. So 75 divided by 18, that gives me 4.17 moles. So I'm going to continue this down here. So Q equals 4.17 moles times my heat of vaporization, which is 40.7. I know I'm going pretty fast. I'm going to multiply these 2 together. The good thing about videos is you can pause, take a brain break, come back, ignore me, put me on mute, just watch me work, whatever works for you. This is in kilojoules. To get it to joules, you have to multiply by 1,000, so you're going to move the decimal 3 places to the right. So that's how many joules there are. That's our second answer. That was our first answer. Let me back up so you can always pause if you need to digest any of this. It tastes super yummy. I got no idea what I'm saying. Q equals mc delta T. This is going to be step 3. The key thing is mass does not change, still 75 grams, but now our C does because we have to use the C for the state of matter we're in. So we're going to multiply 2.01 times our delta T. Now the delta T is only for this section. 110 minus 100, because again this line was at 100, so that means 10. So I'm going to take 75 times 2.01 times 10. Are you guys getting dizzy with how I'm holding this phone? Isn't it just lovely? And you get that answer. Now, what do you do with all 3 of your answers, you might ask? Or not? You add them up. So if I wanted to add them all up, which you can do as well, I don't know why I'm doing it for you, you get a whopping big number. Joules. Or you could pay kilojoules, where kilojoules you divide by 1,000, so you move it to the left. Bam! There's your last helpful video in 6 minutes and 5 seconds. Woo! Have a good night.